was a low-tension rotary magneto connected to a mock-up of an igniter, attempting to show what goes on inside the cylinder as one of our engines is running. The magneto is an Iowa dairy. You might recognize it as an associated 2-bolt. You might also recognize it as a John Deere magneto. It, however, was running with a magnet, which I manufacture and I call EVAC. I sell these magnets for $125, no shipping. This magnet will cause this magneto to produce a 600 to 700% hotter spark at 400 RPM. Before I get into the magnet, I think it's interesting to take a look at how a magneto works. As you may well know, the igniter prior to trip is always shorted. In the case of the John Deere, the igniter remains closed for the full duration of the cycle. In an associated, the igniter closes some 30 degrees or so before it trips or before we need ignition. But for all intents and purposes, in the area of interest, the igniter is shorted. So, in this case, I have the magneto sitting here. The key right now is pointing in this direction. In slow motion, as the magneto turns, at this position there is zero current out of the magneto, even though it is shorted to ground. But as the position of the armature turns and it reaches a point where the key is straight up and down, then the current has built up to about an amp coming out of the magneto through the igniter to ground. As the magneto turns further, that current decreases and eventually reaches zero when I'm 180 degrees from where I started. Now, as the key starts moving towards the bottom, the current starts to build again, and when the key is of straight down, there is about an amp of current flowing. This time, however, the current is coming out of ground through the igniter back into the magneto. Then as it finishes its turn and we've completed a revolution, the current goes back to zero. So in a revolution of the magneto, current first comes out of the magneto through the igniter to ground, then turns around and comes back through the igniter back into the magneto. Now, why is the igniter shorted during all of this? Well, it's an interesting physical phenomenon. It involves a coil and current. The coil in our case is the armature in here. The armature is a core with hundreds of turns of wire around it, which is sitting inside. So we have a coil and we have current flowing. Physics says you cannot stop that current instantaneously. You can try, but you cannot stop the current instantaneously. So what happens is the magneto is shorted, the armature is coming around, current is flowing, it gets up to about an amp, and all of a sudden you open the igniter. The current must continue to flow for a short period of time. The only way it can do that is to jump across the igniter points, which results in a spark. Now, before I get to the hotness of your spark, just a couple of interesting things. You saw me turning this magneto in the clockwise direction. That's the way John Deere turns it. The associated turns it in the counterclockwise direction. What happens is the current goes in the opposite direction for the same location. So when the keyway is down for a counterclockwise direction, the current is coming out of the magneto going to ground rather than coming out of ground going back into the magneto. So it turns out John Deere trips their magneto up here, Associated trips their magneto down here. Now, another interesting phenomena, if you take this magnet, pull it out, turn it 180 degrees and drop it back in, you will get another reversal of the currents. So it makes no difference in our engines whether you trip at the peak of current when it's going into the magneto or whether it's coming out of the magneto. The engine will run the same in either case. Over the hundreds of hours that you might run your engine, you would see no difference whatsoever. Over 100,000 hours or so that engine manufacturers were looking at, you would see a difference in the way the pitting in the contacts of the igniter occur. So they generally have a preferred direction for the current to flow. So let me back up a bit and ask, how hot is that spark? Well, physics again helps us out. Turns out the energy in the spark is merely the inductance in this coil multiplied by the current squared. Now the inductance is it's a number. It sounds pretty complicated. It really isn't. It has to do with the number of turns on this coil, and it has to do with the size of this core, the material of the core, and another number of things. Over the many, many years that Iowa Dairy made this magneto, it's unlikely that the inductance of the magneto changed by 10%. So it's just a fixed number. So really the hotness of your spark is related directly to the current squared. As I said, if we have a good magnet, a good standard issue magnet, and we're turning about 400 RPM, and we're timed properly, we will trip when the current is about an amp. So 1 amp squared is 1. Now, let's assume that I've got a weak magnet and or I've mistimed my igniter trip and it trips at about 7/10 of an amp. Doesn't sound like much of a loss, but 7/10 squared is 0.49. And you will now have a spark that's about half the energy or half the hotness of a good associated or John Deere magneto. Now this magnet, which I call EVAC, will cause the current flowing in this shorted igniter to be at more than 2.5 amps. 2.5 squared is 6.25. So the hotness of your spark, if you run an EVAC magnet, will be 600 to 700% hotter than the standard issue magnet. So the real way to measure the output of your magneto to see if it's in good condition or not is to measure the current. Everybody measures the voltage, but it's a very poor indicator of the performance of your magneto. In another video in a day or two, I will post showing a real simple way to measure the output of your magneto, which is by far a better indicator than measuring the voltage. For questions, I can be reached at email at jdengines@cox.net. That's JD like John Deere, engines as in plural, at cox.net. That's cox.net. jdengines@cox.net. Or I can be messaged here on Facebook. Thank you.